So let's just review the solving equations that we looked at yesterday. These are all one-step equations, remembering that we have to do the opposite operation. So 2y equals 12. If it's 2y, that means 2 times y. The opposite operation is divide, so we need to divide both sides by 2. And then, of course, that will leave us with 12 divided by 2, which is y equals 6. Same thing here, the rules don't change if I have a negative. We still have negative 8x, which means negative 8 times x. So the opposite operation is to divide. But be careful, we have to divide both sides by negative 8. So on the right-hand side, we have negative 16 divided by negative 8, which means x equals positive 2, because a negative divided by a negative is positive. Opposite operations continue whether we're dividing or multiplying. Here, it's x divided by 2, so the opposite operation to dividing is to multiply. So we need to multiply both sides by 2. And negative 4 times negative 2, and negative times a positive is negative 8. So x equals negative 8. And finally, p minus 7 means what number do I subtract 7 to get negative 3? So of course we do the opposite operation. We have to add 7 to both sides, which leaves us with negative 3 plus 7. Remember, if negative 3 is kind of cold, adding 7 gets us warmer. We're at positive 4, and p equals 4. So that should be a bit of a warm-up from our last class. And now we'll move on to solving more equations, but with 2 steps. Actually, sorry, one more example. This just ties back to our fare question where we have $3 per ride plus $10 to get in. So these are the types of questions we're going to look at in this lesson, but recognize that the same idea still applies. If you recall from when we did this before, we have to sort of ignore the 10, take that out of the situation by subtracting 10 from both sides, and leaving us then with 3x equals 18. We know that $10 must have been spent to get in. That means we spent $18 on rides. If it's $3 a ride, we're going to divide both sides by 3, and we know that we have 6 rides. So this is just combining the one-step operations that we did over here, where there's like a subtract or an add and a divide, but doing it in 2 steps. And that all of this then gets us our answer. Sometimes we have to take a couple of steps to solve for x. So we first must isolate the term with x in it, then isolate x itself. So just like we did in the fare question, we're going to get rid of our constant term first so that we can isolate the term that has x in it first, then isolate for x itself. So the first thing we have to deal with is this minus 17. We still do our opposite operations. We're going to add 17 to both sides. And 28 plus 17 gives us 45. And then we've successfully isolated for 3x. Now this becomes a question just like our warm-up question. One step, 3 times the number equals 45. Have to do the opposite operation, divide both sides by 3, and then we get x equals 15. In the second one, our steps are still the same, regardless if we have a negative. We see that the first thing we have to get rid of is our negative 10. So the opposite operation is to add 10 to both sides, and we get a negative 2x equals 14. Being careful of our negative sign, we have to divide both sides by negative 2, and we get x equals negative 7. Regardless of where that x is, we're still going to perform the same operations. We've got to get the term that has x in it by itself. So this thing we have to get by itself. So what I'm going to try and do is isolate that by doing the opposite operation on 7. This is a plus 7, so the opposite operation is to minus 7. But of course we have to do it to both sides. Be very careful here. If I'm getting rid of this negative 7, I'm left with a negative x. And the 1 minus 7 gets us a negative 6. So I have this negative x, which remember, if it's negative x, there's a coefficient of 1. There's a number in front of it. We're still going to have to divide both sides by negative 1 to get that the answer is x equals positive 6. And if we go back and check that, it should make sense. 7 minus something is 1. That something has to be a 6. So 7 minus 6 equals 1. And regardless of whether the numbers work out nicely, our operations are still the same. We have plus 8, so our first idea is to subtract 8 from both sides, leaving us with 6x on this side, and 4 minus 8. So 4 is now kind of warm, but minus 8 makes us colder, and we get us into the negative 4. So 6x equals negative 4. Divide both sides by 6. This time it doesn't work out nicely. We end up with a fraction. It's okay to stay with fractions. We could go to decimals as well, but it's okay to stay with fractions, provided they're in lowest terms. So divide both the top and the bottom by 2, we get that x equals negative 2/3. This shows how this process is really important to follow, because you're not going to be able to just guess numbers all the time. In C, we probably could have looked at it and said 7 minus a number equals 1. We all probably could have got x equals 6 right away without all this process. But I would challenge that it's much more difficult to figure out x right away in this question. I don't think I would have guessed that x was negative 2/3. The process helped me get to that point. So this is where I want us to practice this process throughout these questions, regardless of if you might be able to figure out the answer on its own. The point of this is to practice our process so that we can answer more complicated mathematical questions.